Hello everyone. Today we will see the topic on the introduction of power system automation. First we will see the basic definitions or terms related to the power system automation. So the power system automation can be defined as the mainly it is the system of planning, controlling and protecting the system, or we can say the monitoring also. And this is accomplished by obtaining the real-time protecting in the power system. So what is real time? Actually, real time means the actual system or the actual practical system that we can say that it is a real time operation. So in the remote control applications and the advanced electrical protection, we can, these terms are used in the power system automation. The core ingredients of the power system automation system are the local intelligence, data communication, and the supervisory control and the monitoring. So we will see first what is the power system automation. Power system automation, basically there are the some definitions or some terms are included like the electrical protection, control, measurement and monitoring, and the data communication. These components or these elements we can see one by one. This is the figure of the power system automation that we have seen in the circle diagram. First is the electrical protection, monitoring, measurement, control, and the data communication. Then what is meant by the electrical protection? We will see one by one. The electrical protection is still one of the most important component of the electrical switchgear panel. In order to protect the equipment and personnel and to limit the damage in case of the electrical fault. So the first and important thing in the power system automation is the protection. So we have to do the electrical protection is very well. So electrical protection is a local function and should be able to function independently of the power system automation system is very necessary. Although it is an integral part of the power system automation under the normal condition. We have to do the protection under the normal condition. Before the fault occurrence, we have to protect our system very well. So let's see, the next is the control. So how to control the system? Control includes actually the two parts, that is the local and the remote control. In local control consists of the actions and the control device can logically take by itself. For example, the interlocking or the switchgear sequences or the synchronizing chain. These are the local control means at the time of the protection, we have to do this control. We can do it is by using the human intervention also. And the remote control means like if the fault is occur in the another place, okay, and we have to control that fault in by using the some elements or like the SCADA, or there are the certain systems are there that we have control in one room. So that is called as the remote control, means there is a distance is included if the distance is far away, but we can control that system. That is called as the remote function. In remote function, there are the SCADA, PMU stations are included. That gives the basically the data that we have record from the systems, and then we have to control it. Then third one is the measurement. A wealth of real-time information about the substation or switchgear panel is collected, which are typically displayed in the central control room or stored in a central database. The measurement there are the again three types are there. By using these three types, we can measure the database. Then the electrical measurement. In electrical measurement, there are the voltage, current, power, and power factor and harmonics that we can measure by including the metering system. And the second one is the analog measurement. For example, the transformer and the motor temperature. that we can measure by using the analog meters also. And then third one is the disturbance recording for the fault analysis. Then disturbance recording, there are again some elements or some meters are placed in the for using the fault and for measuring the fault analysis, and that is measured by using the disturbance recording. Then it makes it necessary for the personnel to go to the substation to collect the information, or sometimes we can measure it from the remote terminal stations also, or the remote control stations also. So these are the measurement. Then next one is the monitoring. Then in monitoring, then all this system, first we have to the protect the system, then control the system, and then measurement, and the next is the monitoring. So by using the monitoring is very necessary. Then sequence of event is recorded by using the monitoring, and the status and the condition monitoring include the maintenance information also, and the relay setting is also comes under this monitoring section. This information can assist in the fault analysis, determining what happened, when it is happened, and where it is happened, and what is and in what sequence that will happen. This can be used effectively to improve the efficiency of the power system and the protection. Then prevention maintenance procedure can be used by the condition monitoring information obtained. So monitoring is very necessary in the power system automation also. Then next is the data communication. Data communication forms the core of the any power system automation system, and it is virtually the glue that holds the system together. Without communication, the function of the electrical protection and the local control will continue. And the local device may store some data, but the power system automation cannot the function. Then by using this data communication, we transfer the measured data from one place to another place, and for that purpose we require the communication. So power system automation architecture, this is the basic architecture that I have shown here. First is the SCADA. Then how the SCADA works. Actually, there is a communication network, or we can say the data communication. Then the object divisions is also there. Now we will see this one by one. Then first is the object division. The object division of the power system automation system consists of an intelligent electronic devices and the modern and the third generation microprocessor based relay is also there, or the remote terminal unit is also there, and we can again use the PLC system is in the object division. This receives the analog input from the current transformer, voltage transformer, and transducer in the various switchgear panels, as well as the digital inputs from the auxiliary contact is also received, and that will give the output either to the SCADA master or the other field instruments. So these are the object division consists of the process level and the bay level also. Then next is the communication network. The communication network is virtually the nervous system of the power system automation. The communication network ensures that the raw data, processed information, and the commands are relayed quickly, effectively, and error-free among the various field instruments. The IEDs and the SCADA system. The physical medium will predominantly be the fiber optic cable is also used. By using that system, we can use the communication network. Then next is the SCADA master. SCADA, the full form of the SCADA is Supervisory Control and Data Acquisition System. The SCADA is actually we can say it is the brain of the power system automation. The SCADA master station, we can say it is the SCADA master station, receives the data and the information from the field, decide what to do with it and store it, and issue the request or the command to the remote devices, and so that remote devices will be operating in nature. So therefore the SCADA master is effectively in control of the complete power system automation. Now, the SCADA master consists of simply of an advanced, reliable PC or the workstation, and the SCADA software is also there. So, SCADA is actually the big topic. So, we will cover it in the later. So, thank you.